what is the radiation? Let us discuss now radiation. So, first part, a variety of radiations are available. Say for example, certain radiations are made up of particles. For example, you might have heard about alpha particles. Elements like radium, they are emitting out alpha particles. So, alpha particle, this is particle-based radiation. Beta particles, particle-based radiation. Cathode rays, particle-based radiation. So like that, certain radiations, they are made up of particles. High speed particles, say for example alpha particle or alpha rays. Minimum speed of alpha rays is 3000 km per second and maximum speed is 30,000 km per second. So here we are getting different speeds of alpha particle, but you can easily consider 3000 km per second too high speed. Within less than second, particle can travel from Mumbai to Delhi. That is the speed of that particle, which is we are calling slow moving alpha particle. Whereas fast moving alpha particle, 30,000 km per second. So like that, very high speeds are there for alpha particle or like that radiation. Then we are calling that as particle based radiation. Another type is there that is called as electromagnetic radiation. Now here we are going to discuss little bit about electromagnetic radiation. But prior to that, third type of electromagnetic radiation only, but we are calling them as lesser. Lesser is short form, but we are calling that category of radiation as lesser radiation or laser radiation. Okay. Now let us consider once again electromagnetic radiation. The first type of electromagnetic radiation let me clarify once again. These radiations are having certain energies. I am revising. Radiations are associated with energy. Do you agree? Simple experiment. You are aware of instrument microwave oven. Microwave is category of radiation only. And if you are keeping object in that microwave radiation, microwave oven, then you are getting it hot. Okay. So radiations possess energy. Still don't believe? Just go and stand in sunlight at afternoon time. You will get tremendous heat by that sunlight. That is also energy possessed by that radiation. So every radiation is associated with some sort of energy. Maybe it is very high, maybe it is very low. Now we are arranging all these radiations according to energy. So I will explain you these radiations in decreasing manner of energy. Highest energy radiation, that is supposed to be cosmic radiations. But no much of the research is available about these cosmic radiations. Many doubts are there. So I am not considering cosmic radiation right now here. So if you eliminate this cosmic radiation, then in the known radiation, gamma rays, they are having highest energy. So we are starting our chart with gamma radiation. So gamma rays having highest energy, then X-rays. Now there are variety of X-rays, but we are considering here only single thing, that is X-ray. Then vacuum ultraviolet. These ultraviolet radiations are having existence in vacuum. The moment it enters in atmosphere, within short range, they get absorbed by atmosphere. Therefore, we are calling them as vacuum ultraviolet. Then ultraviolet, you are aware from many TV advertisement, you are aware of these type of radiation. They are called as ultraviolet radiation. And from TV advertisement, it is very clear for many of us that ultraviolet radiations are harmful. But reality, no. Ultraviolet radiations, all categories of ultraviolet radiations are not harmful. Few categories, yes, certainly they are harmful, but not all categories of ultraviolet radiations, they are harmful. In fact, ultraviolet radiations are very, very essential in order to synthesize D vitamin in our body and by our body. That's why we required ultraviolet radiations also. So they are present in atmosphere. How you can check ultraviolet radiations are present or not? Because they are invisible radiations. Simple test I will tell you that if ultraviolet radiations are present, then you are aware of fluorescent colors. So fluorescent color that appears bright in presence of ultraviolet radiation. In absence of ultraviolet radiation, fluorescent color is not appearing bright. You may check LED. So in LED light, fluorescent objects are appearing brighter. You may say tube light, ordinary tube light. In that tube light also, objects are appearing brighter, fluorescent object. But if you, now it is very rare, but if you check tungsten lamp, then in tungsten lamp light, you will see fluorescent object is not that brightly observed. The thing is that tungsten lamp is not emitting out much of ultraviolet radiations. But tube light, LED light, they are emitting out good quality of or variety of ultraviolet radiation. And daylight, obviously, sunlight is very good source of ultraviolet radiations. And they are reaching to surface of earth. Now, high class example, there is reaction between methane and chlorine. It is taking place in presence of ultraviolet radiations which are present in diffused sunlight. Diffused sunlight means what? Say suppose outside your room direct sunlight is there and that is reflected light is coming to your room. Then that light is called as diffused sunlight. In diffused sunlight also these ultraviolet radiations are present and they are able to carry out reaction between chlorine and methane. So this is something I am explaining about ultraviolet radiation. So let me clarify once again. Gamma radiations, X radiation, that is X-rays, then vacuum ultraviolet, ultraviolet. All these four radiations we are considering as invisible radiation because we are not able to observe them. But energically they are very high energy radiation. Obviously decreasing energy. So gamma rays highest energy, then X-rays, then vacuum ultraviolet, then ultraviolet. Keep aside. Now violet, indigo, blue, green, yellow, orange and red. VIBGYOR. Only these radiations are observed by us. We are able to observe only these radiations. So they are called as VIBGYOR, visible range of radiations. Next, infrared, that is below red color, therefore called as infrared. Then far infrared, then microwave, and lastly radio waves. So least energy is possessed by radio waves. Now these radiations we are going to explain in details, somewhat detail than what I am explaining here, to that somewhat detail in atomic structure part, and then we will have a separate lesson about these radiations. There we are going to discuss at depth. So you can able to revise this radiation in atomic structure part also. So now we are discussing this about universe and therefore I am focusing till here. So whatever you are observing night sky, that is only visible light. Invisible radiations we are not able to observe. Now from earth we can't observe gamma rays, X-rays and vacuum ultraviolet rays if at all they are emitted by any object. But if you are there in the space, that means you are going beyond the atmosphere, then we can able to detect, I can't say observe, but can able to detect these radiations with help of certain telescopes. So for example, certain telescopes are there in the space. Say for example, Chandra X-ray Observatory. Chandra is not considered here as moon, but Indian scientist name work for NASA. His name is given to that X-ray observatory. In space science, he proposed that what is the minimum mass of star that is required so that it can be converted into black hole. That is called that Chandra limit. On basis of that scientist's name, the X-ray observatory is given name as Chandra X-ray Observatory. Other all observatories are there. They are working in this range. Even Hubble telescope is there, which is working in visible as well as to certain extent ultraviolet and maximum extent infrared radiation. So invisible radiations are there in the space. Various observatories obviously not sent by India yet. Their maximum observatories are sent by NASA only, that is from America, USA. So they are working in the space and we are able to aware about that. So for example, if you observe sun, now there are filters. Filter means what? Which will allow only one radiation to pass, rest of radiations get stopped. For example, gamma rays filter. Gamma rays filter will allow only gamma rays to pass, remaining all radiations will get stopped. So if you are using gamma rays filter and taking photograph of sun and photograph of moon, then moon may appear million times brighter than sun. Okay, moon is very good source of gamma radiations. But because gamma radiations are having very small range in atmosphere, so for example on this surface of earth, hardly 10 to 12 centimeter distance is traveled by gamma rays. And upper parts of atmosphere, obviously rare atmosphere is there a little bit more. But gamma rays are not reaching to the surface of earth. They are emitted by moon. So in the space, we can able to observe these radiations with help of instruments only. Now, visible light, obviously visible light is reaching to earth's surface. Many students are having doubt how we can say, because we are able to observe sun, we are able to observe moon and whatever night sky objects, that means that visible light is coming to earth's surface. No doubt partially it is getting absorbed by atmosphere. 100% visible light is not reaching to the surface of earth. Partially it is getting absorbed by earth's atmosphere, and then only it can reach to the surface of earth. It depends upon the quality of atmosphere, what is the percentage that is getting absorbed. But usually we are going higher the altitude. Say for example, I am going to Himalaya, particularly trans-Himalayan region, beyond Himalaya. There is a cold desert of Ladakh, Leh Ladakh desert is there, where we can observe these objects brighter. The thing is that atmosphere is very, very clear, and we are there above 5,000 meter altitude, 4,000 meter altitude, and then chances of haze, that is mist, that is also not there. If you are going to higher the altitude, obviously we can observe stars as well as these all planets and all things more clearly. And therefore the telescope, that Hubble telescope is their mirror telescope, which is there in the space. So that telescope is having very clear vision. Now apart from that, infrared radiations are also there. They are also little bit absorbed by atmosphere, but many of them are reaching to surface. But such observatory is kept in space. That is called a Spitzer infrared radiation observatory. So we are having this type of various things in the sky, whereas microwave and radio waves, they are reaching to Earth's surface. Keep in mind, the energy is low, range is more. So radio waves are having tremendous high energy, tremendous low energy, therefore tremendous high range. And so one such radio telescope is there in India. In present India, in Maharashtra, there is a district called as Pune district, where the location is near Narayanagar. We are having a very good radio wave telescope. Now this telescope, don't be under impression that telescope means we have to use your that tube is there and you have to go through that. No, here radio telescope is there, that is in form of dish antenna. So various dish antennas are there, huge dish antennas are there, and they are collecting out radio waves, and with help of computer and all that, images are generated. So how we are getting this knowledge about this universe? The obvious thing is that through all these radiations, right from gamma rays to radio waves, whatever the radiations are there, from that we are getting knowledge about this universe, because that we can see either directly or with help of our instruments. But tremendous matter is there which is not at all emitting any radiations. That is called as dark matter. So now you are aware, after all this discussion, what is dark matter. Dark matter is not at all emitting any radiation. That is having temperature as absolute zero. That means 0 Kelvin. That means minus 273 degrees Celsius. And therefore it will not emit any kind of radiations, and we are not able to see that dark matter. How much this dark matter is there and how much some other part is also there. That is called as dark energy. Because energy, now let us consider now about energy. What you are able to observe, radiations, that is form of energy only. Energy can be expressed in various forms, mechanical energy, heat energy, like that. So you are aware of kinetic energy, potential energy. So these are form of energy. In old physics, two things were considered separate. Keep in mind, just focus, it is somewhat more important. In old physics, matter was considered as separate and energy was considered as separate. But in latter phase, because of the great scientist Albert Einstein, he was able to give formula, that is E is equal to m into c square. C is speed of light. Square of that was energy is there. According to his formula, matter and energy, they are interconvertible. So one can convert matter into energy or energy into matter according to his formula. In later on, with help of this formula, scientists like de Broglie, they suggested dual nature of matter. They say at a time matter is there and at a time energy is there. This is beyond my imagination. But they are able to prove, these scientists, that at a time particle like electron can be considered as a wave or can be considered as a particle. And then onwards, we are aware that matter and energy, they are interconvertible, or many times we are considering now dual nature of matter, that matter as well as energy. So we have to go by that concept now. So in this universe, matter is there and energy is there. But now we are aware that many energies we are not able to get yet. And then the energies which we are not able to explain, we are calling them as dark energy. Clear? So dark energy, that energy we are not able to explain, that is called as dark energy. Togetherly with our present knowledge, total dark matter and dark energy in this universe is about 96%. I don't know how they calculated, but they say, they mean scientists, they say total dark matter and dark energy is about 95 to 96%. That means today scientists are aware about this universe hardly 4 to 5%. Getting idea? So today is the greatest scientist, because say I can consider Isaac Newton as a great scientist, I can consider Albert Einstein is a great scientist, but at their time the scope of knowledge was very limited. Generations after generation, knowledge is expanded. Isaac Newton was not aware of these all radiations, or rather I should say that these modern techniques and all that. But today's scientists, they are very great, and still we believe that we are aware about this universe just 4 to 5%. 95 to 96% universe not clear to us. And then we are talking about superstitious belief. So we have to consider anyhow. So I am revising again. I am revising this part again, that whatever the energy that we are not able to explain, that is called as dark energy. Whatever the matter that we are not able to see, because it is not at all emitting any radiation, that is called as dark matter. Togetherly, dark matter and dark energy, that comprises of 95 to 96% according to present knowledge. Okay, so this is something we are just discussing, overview of the universe.